Now, since we've done this, I would like to show you one final thing that is related to SSH. I would like to show you how you can copy pretty much anything from one point to another. This can be done regardless of the distance and of the size. For example, this is something that people do on like they create something on their home machines, like they create a website or something of a kind, and then they copy it over to their cloud somewhere where the site becomes alive. You can also copy your entire SQL database. It is all dependent on you. You can combine SCP with tar. I showed you how to use tar in the previous tutorials, so you can create one huge tar ball. You can create a tar ball of 100 gigabytes or something of a kind, and then you can use the SCP command to basically copy pretty much anything from any point to any other point in a secure, encrypted fashion, which is very useful and very nice. So I am now on my server over here, and I will go ahead and enter desktop. I do believe that I have a file here. It's called example. Now I will copy example from my server, from the CentOS SSH server, onto my Red Hat client. In order for us to do that, well, let me just show you that I don't really have anything in the path. I will copy it into downloads, and let me just show you that I don't really have anything in downloads. So, well, I do have some things here, but I definitely don't have a file under the name of example. So let's go ahead and copy the file. Let me see if I have a command memorized here. I do. There we go. So this is the syntax for copying local files to a remote site. I would advise you to go onto the net and just type in SCP usage examples using your favorite search engine. Examples are numerous depending on what your purpose is, but it's fairly similar always. It doesn't change that much. It just allows you to copy things from one end to another, and it allows for the encryption layer to exist so that nobody can see even though somebody could possibly capture traffic in between, they couldn't actually see what it was because it's encrypted. And let me just go ahead and press enter. Well, before I do, I'm sure you understand this is a file here. This is a command SCP. This is a local file. I could have also typed in here. I could have also typed in front of the example something like this: path to the file. I could have also used this and specified a path to the file, but since I am already in the desktop folder and the file is there, it doesn't really matter. I can just go ahead and use it like this. Then I specified the username on the remote site. I specified the IP address, and I also have the directory. So you put a colon here, and then you specify a directory on the remote site where in which folder do you want to copy this file. Simple as that. Just go ahead and press enter. It will prompt you for a password. Press enter. Permission denied. Okay, me and my passwords. Excellent. So there you go. The file has indeed been copied. Let's go over to this other screen and type in ls, and you can see that the example is there. Let me just show it like this to you. There you go. It's right there. I have managed to copy it. As I said, the file size doesn't matter. You could copy an entire database in this fashion. Anyway, I bid you all farewell and a ton load of luck. Welcome all to this tutorial. Today I will talk about partitions and partitioning. In Linux, it's fairly simple. However, you do need to use the command line interface, but the commands are not complicated at all. For partitioning, they're rather short and pretty easy to comprehend. This is not a difficult chapter, but a relevant one in any case. But it's not very difficult. It's not very challenging. The commands are short and simple, easy to understand, and easy to remember as well. Let's go ahead and begin with known file systems that are used. So XFS is one of them. That is the default file system of Red Hat and a lot of distros today, a lot of significant distros today, the bigger ones anyway. It is very fast, and that is its primary advantage is the speed over ext4, which is a lot slower than XFS. There are some other differences, but that's the primary one, the speed. The speed difference you wouldn't probably notice on a file system, which is maybe 100 gigs total size. But imagine if you had about 100 terabytes or even a petabyte, which is 1000 terabytes. And if you were searching for a file in that system, and if you were using ext4 over XFS, you would definitely notice that it's a lot slower. It's been around for a while, ext4, and it's really old now. It's been built for systems that didn't really have a lot of capabilities in terms of storage. Back then, storage was measured in megabytes, so hard drives were actually in megabytes, so just keep that in mind. Anyway, next up we have VFAT. VFAT is for compatibility primarily. This is something that you would use to format your USB drives or portable storage for the sake of compatibility with other operating systems such as Windows. Now, it's not a good idea to actually format your partitions as VFAT in your desktop machine or in your server machine, because I just in this moment I instantly saw like 100 people thinking, oh, I'm going to format all of my partitions with VFAT, and then I can share all my drives with my Windows machine. True, you could probably do that, although then you might as well format them as NTFS. NTFS, this is a file system used by Windows, but this is not something we do in Linux. That's equal to heresy, and you would significantly hinder your operating system. So just use XFS, which is it's not the latest one. There are some other ones that were supposed to come alive this year, but with Red Hat 7 and 7.1, but it would seem that XFS has remained persistent, and it has stayed the way it is. Anyway, in order for us to have a look at the partitions, well, we can either type in fdisk-l. Fdisk is a fantastic utility. It has been around with us for quite a long time now, and it has served pretty much all who have used it very well. Here we can see some interesting information. You can see dev SDA1, SDA2. These are the two partitions. SDA, that's the disk up there. So it says dev SDA, and down here it says dev SDA1 and 2. These are the two partitions of the disk SDA. Now, I don't believe I have another disk here. No, I do not. This is a bit difficult to see, especially if you are starting up with this. It's kind of difficult to figure out what is what, where is what. For the time being, I would advise you to focus yourselves on this first line here, and then follow up on what is written down below immediately. So there we go. So where it says devices, and I don't know, it says boot, and then it has a markation for boot, where it's booting from. Where is it booting from? You don't actually need to pay that much attention to these lines here, as they are not that significant for you at this point of time. But like this, you will be able to see the partitions of the disk. You will be able to see the disk, the device itself. Another way of doing this is by typing in cat proc partitions, and proc is basically communication of the kernel with the user. Well, I wouldn't put it like that, but it's a fantastic way to see the things that the kernel is doing, because in Linux everything is a file, so even the things that the kernel is doing are being written out here so that you can actually see them. So these are the partitions and the disks that are known to the kernel. didn't have to list the partitions. I could have done